In this video, we'll be solving a problem that involves a dartboard. The problem comes from the Explorations Manual, Activity 1.4. In particular, we will be looking for and analyzing patterns in the dartboard. Once we find patterns, we're going to work on an elementary level proof to understand why that pattern makes sense and help us make predictions based on the pattern for future dartboard problems. So let's look at this problem. We have this dartboard right here, and we're assuming that we throw 4 darts and that every dart lands on the dartboard within one of the rings. The way that you get a score in a game of darts is each dart contributes to your point total, and you add up the points based on how much that ring is worth. So for example, if we were trying to score 6 points, we could see that if we had 3 darts land in the outer ring and 1 dart land 1 ring in, that would be 1 plus 1 plus 1 plus 3, or a total of 6 points. So it's possible to score 6 points. In a moment, I'll have you pause the video and see if it's possible to score these other point totals. You're welcome to just randomly try numbers. You're welcome to do an organized guess, check, and revise type table where you base your next guess on learnings from your previous guess, or do some kind of more systematic process where you go through all the different combinations of numbers. But that one will get quite long. There are a lot of different combinations that you could get here. Once you have done that, then I want you to look at number 2 and think about what kind of scores in general are possible. What's the lowest score? What's the highest score? Can you score every number in between? And look for some patterns and think about why those patterns exist. Then come on back and we'll talk about the answers. Welcome back. Hopefully you've had a chance to think about these problems, and what you should have found is that it's possible to score 10 points, 20 points, and 28 points, but we can't get the odd ones. I'm not going to go through the thinking to get to these, but I will flash up on the screen here, and you can pause if you'd like to, some ways that you can come up with these point totals. So one thing that you might notice is that we were able to get even point totals and not odd point totals. That's going to help us on number 2 here, where we're predicting the kind of scores that are possible. So for number 2, let's think about what the minimum score is. Well, the minimum would come from 4 darts hitting the lowest point possible. So we'll have 4 darts, each hitting the 1-point ring. As a side note, when I label each of the numbers in my calculation, I'm writing an annotated equation. It makes it easier to follow someone's work when you can see what each of the numbers stands for, rather than just having a kind of a mess of calculations down on a paper. All right, so 4 is the minimum. Let's look at the maximum. Well, again, we'd have 4 darts, and this time they would all be landing in the bullseye, and so the highest score would be 4 times 7. So we know that we're going to have a range of scores that go between 4 and 28. And based on our results from number 1, we're going to guess that all of the scores are going to be even. Now, one thing that I didn't show you that was in the Explorations Manual, up here they had the answer to start with, which is sort of a curious choice, but you can see that here's the answers that you could get, and these are suggestions for how to talk to elementary students if you were doing a dartboard type problem. So asking if anyone sees a pattern, and one answer would be that odd scores are impossible, and now we're going to try to figure out why are odd scores impossible. This is a great thing for teachers to understand why the answers are what they are. To do this, we're going to explore even and odd numbers using a 10 frame. So here I'm at a virtual 10 frame, And a 10 frame is just a grid with 10 spaces. We use them because we work in the base 10 number system. And we're going to use this to understand our even and odd. I'm going to put two 10 frames down. And let's start with even numbers. So let's start with the even number 4. And the way that I arrange these counters, so I'm representing the number 4 with a collection of objects. And I'm going to put these discs, these red discs, in pairs. So 4 is 2 pairs of 2. And then let's look at another even number. Let's look at 6. Again, I'm going to arrange the number in pairs. It turns out that even numbers can always, when represented as a collection of objects, be grouped into pairs. If I were to look at an odd number, let's look at 3 and 5, you can see that I always have one extra. It isn't possible to have just pairs. We'll have this odd man out, if you will, the one extra. Well, when we had our dartboard, all of the rings were odd point totals. So when you take two odd numbers and add them together, like 3 and 5, what happens is that the lone disc, the +1, if you will, on here, the odd man, suddenly gets a pair. When I move these and add them together, the two unpaired discs suddenly become a pair, and I have an even number. Everything has a pair because the +1s came together to form a pair of 2. Every time we add two odd numbers, we're going to end up with an even number because the lone disc there, the odd man out, the +1 is going to join to get a pair. Let's look and see what happens when we add two even numbers. So we'll come back here to our 4 and 6. Well, we didn't have any unpaired discs in our collection, so now we're just grouping a bunch of pairs, combining a bunch of pairs together. So 6 plus 4, we know, gives us 10, and we're just rearranging here, and we still have pairs. So we still have an even number. Finally, if we take an even number plus an odd number, let's take 3 plus 6. Well, the 3 it's odd, so it has that odd man out, it has that lone disc, the +1, but when we add it to an even number, there isn't an odd man out, there isn't a lone disc to join together. So as we combine these together, 6 plus 3 gives us 9, and we still have that unpaired disc, so we form an odd number. So we have, when we add even and odd numbers, we get an odd number. When we add odd plus odd, we get an even number, and when we add two even numbers, we get an even number. We can use this to make some predictions and to explain. So in this problem that we had here, we had 4 darts and they each landed on an odd number. So let's come down here to some blank space. So we had odd plus odd plus odd plus odd. Two odds together, we had those unpaired parts coming together to form a pair, so we get an even number. Then we have an even plus an even. Everyone's already got a partner, and we end up with an even answer. So all of our answers are going to be even if we start with 4 odd numbers. If we change this problem, if we made a new dart problem and say only added 3 darts together, right away we can figure out that our answer, let's see, 2 odds make an even, and then an even and odd are going to give us an odd. We know right away that all of our scores will be odd scores. It's a pretty neat trick thinking about what it means to be odd and even. On a side note, for those of you who might have some background in Spanish or have future students who speak Spanish, if you look at the words for even and odd in Spanish, they seem kind of like the words pair and maybe not a pair. So it works out nicely in the Spanish language.